You are here for an Autodesk Design and Make webinar, the series designed specifically for educators that we launched here in the second half of the school year. This one is our last webinar for the school year, so it's bittersweet moments. We're excited to talk about so many awesome projects and things with you, but of course we are sad that the school year is coming to a close, though perhaps my educators in front of me are beyond excited for summer, depending on where you are in the world. And tonight we have called this Design and Make Anything because we just have so many exciting projects to talk about as we go through some really awesome resources and things for you and your students. So my name is Jason Erdreich. I'm a STEM and engineering educator, and I've teamed up with the Autodesk and Tinkercad team to provide resources like this to educators like you. And I'm joined, as always, by my co-host, Randy, if you want to say hello.
Yes, I am Randy Sarafan. I'm on the Autodesk student community team, and I primarily focus on Tinkercad and Instructables, and I'm super excited to be here.
Yeah. But as always, Randy and I are joined by so many different members of the Autodesk and Tinkercad team. So a huge shout out to Kellyanne and Nicole and Alex and Christian, who have joined us here, who will be helping out with the Q&A and things. And there's even more folks behind the scenes who are working to provide all the resources and exciting things that we get to talk to you about in tonight's webinar. So design and make anything. When we were trying to figure out the theme for this webinar and figuring out how we can kind of end the school year on a really exciting note, honestly, we couldn't make up our mind. There's so many amazing things that we talked about throughout the year, not only in the Design and Make series, but also in our earlier series, like our Teaching with Tinkercad series, our Level Up with Fusion series, where we have been able to engage with you and educators from all over the world with some really cool projects where students are programming electronic circuits or using code to make 3D models that are 3D printed, or designing robots, or manufacturing with lasers and CNCs, or even simulating real world physics and things like that. And to be honest, there's just so many awesome things that we know all of you are doing. And we wanted to take some time before the year ends to really make sure that we're providing you with some powerful resources, some useful resources that hopefully you can turnkey and bring right into your classroom. So we're going to cover a ton of things in tonight's webinar. And as you try to engage with us, there's a couple ways that you can participate. The chat is hugely active, right? So as you can see, the chat's going pretty quickly, so which we love, which we love. And again, I have so many folks with me here tonight who will be entering information for you in the chat. So we'll be dropping links and things like that to help direct you to useful places and everything like that in the chat throughout the evening. But another great place to participate with us is the Q&A area. So there's a Q&A button on your toolbar, and that's where you can drop in a question. And the nice thing about that is when you ask a question, it stays there until somebody from the Tinkercad Autodesk team answers it. So that's super handy for us. So if you have any questions as we're going, again, I'm going to be covering a lot of things rather quickly. Please go ahead, drop that in the Q&A spot, and then you'll be able to go back and see answered questions as well. And then later tonight, after we go through all the content and things, there will be a dedicated Q&A session. This webinar is also recorded. So while we are going to go through things kind of quickly, you can always go back and review the recording. We'll email that to you tomorrow, along with the slides. So the slides that you see have plenty of resources, lots of different hyperlinks, things like that. So we will be sharing that out to you as well. And we'll also make sure that we drop in some past webinars and things, which is on the Tinkercad YouTube channel. So you can go back and review some of the exciting things that we've covered if you missed it. I'm going to dive into some of the awesome resources and things that we can bring into the classroom and work with our students. And we really spent a lot of time talking about two different Autodesk programs, Autodesk Tinkercad, which I saw in the chat many of you are familiar with and love, and also Fusion, which is a more advanced program. And they really do offer students the opportunity to design just about anything and bring in some real world concepts, themes, and challenges and things into the classroom. And we're going to kick things off with what could you do with Tinkercad? And we'll sort of transition to Fusion depending on what we're trying to show that you can do depending on where your students are in their skill level. So Tinkercad actually has kind of three mini spaces or three little mini programs built in. And I say mini, but all three of them are quite powerful. I think it's most widely known for the 3D design space where we can be making 3D models, things to like 3D print or 3D worlds and things like that. There's also a circuit space where you can create electronic circuits and program microcontrollers, and codeblocks where you can use a block-based programming language to design 3D models. And all of this lives in the tinkercad.com application, which you can access via the website, through a web app, which you can also access via an offline app or an app on a tablet or something like that. So pretty much any device that you have can access this. And of course, it's entirely free. So students, educators, makers alike can access Tinkercad for free using a free Autodesk account or an account using one of these supported providers and things like that. And as a teacher, you can even create accounts for your students. So you can kind of create student managed accounts, so you can make nicknames for them and make sure that we are well within student privacy and things like that, which is obviously incredibly important. And that just makes it a powerful tool that should fit into pretty much any type of instructional space. Now, the first thing we're going to talk about is actually the very first thing that we talked about at the beginning of the school year, and that are Tinkercad classes and Tinkercad activities. And I'm going to flip my screen here to show you how to do this live, but you'll see in the slideshow we have some screenshots, we have some text and things, and we also have hyperlinks. And again, this slideshow is going to be shared with you. So please, if you see a link or if I go through things kind of quickly, just remember that we are going to provide all these resources to you as in our follow-up from today's webinar. So I am signed into Tinkercad, and when you sign in as a teacher, you will see the option to go to your classes where you can create a class. Like, for example, I've made this class called Demo Classroom, but I can call it, Period 2 or Robotics or whatever it is. And I can invite students. If I wanted to create student accounts, which is what these are actually student managed accounts that I've created. I can actually go through this here. We have an update, and I can actually create a seat using, let's say, a roster that I can upload, or by actually entering nicknames or things like that. And these are actual accounts that I manage. I can also allow students to join my class using a class code. So if they already have a Tinkercad account or they make their own account, they can join like that. And this allows me to keep an eye on student work. So for example, I can click on any of these students and I could see their activity. I can see when the last time they signed in and did things, and we can see that this student hasn't done much for the last 7 months or so, so I have to get on that. But I can see their 3D designs, I can see their circuits, if they have code blocks projects and things like that. I can sign into any of these programs. So this is the actual student work here. I can look at their project, I can leave a comment and let them know some feedback or things as they are working, which is really great. The other thing I can do is I can create activities. So if I head back to my class, I can create an activity, which is a kind of like a challenge or a way just to organize student projects with different themes, right? So I can create an activity here. I can do a title, a description, things like that. And then students can actually design projects specific to that activity. And if I want, I can actually provide a template for them. So I can offer this template like a chessboard like this. And then students can actually design off that template, which is a great way to support younger students. It's a great way to support students that this is entirely new. Tinkercad's entirely new. Or let's say, for example, you are trying to challenge students to design something for 3D printing, and you want to set up your Tinkercad document to have the work plane to match the size of the 3D printing space that they have. You can create a template for your students to design off of and then provide that directly through activities, which is super exciting. And again, you can see all your student work in a lovely and very easily managed space. So that was the very first thing that we talked about. And I see that we dropped a link to that webinar from way back at the start of the year. I'm now going to dive a little bit more into the 3D design space and show you kind of quickly what you can do here. As we create a new 3D design in Tinkercad, this is where we can grab basic shapes and manipulate these shapes to turn them into really just about anything. So I have this box here and I can transform it by changing the size of the box. And if I, let's say, made a copy of the box, I could turn the copy into a hole. So you can see we can have solid shapes and hole shapes. And if I put the hole shape in the solid shape and group the two together, I've now turned this into sort of a box tube-like thing. And I can undo that and I can manipulate this a little bit. So for example, if I were to raise this whole box off the ground a little bit and then regroup it like so, then I actually have some type of storage system, right? And maybe if I wanted to, I could make another copy of this and scale it up a little bit and shrink it a little bit and turn it into some type of lid like this. And now I have a nice little storage box, which perhaps I could download and 3D print if I wanted to, right? So that's just one thing that you can do with Tinkercad. But Tinkercad is not just for designing models that can be exported like this to be 3D printed, right? I could use this to just create three-dimensional spaces, three-dimensional worlds. So for example, if I were to, let's say, flip this box over, perhaps I put some more holes in this where I can grab some different size boxes here. Momentary pause. Modeling live is very difficult, very hard work here, folks. And I can bring some things in like this and group all this together. And now my box has kind of sort of turned into some type of building, right? So I can use these basic shapes to really unleash my creativity, and as can your students, of course, to really create just about anything. And while we have these basic shapes here, there are many, many, many different shape categories, right? So if I head over to scenery, I can maybe find some nice trees to put in front of my home here. And if I wanted to, I could really elevate my window skills quite a bit if I bring this in. And what I'm doing is I'm working in computer-aided design, right? That is what CAD stands for. And these are the same types of skills and concepts that perhaps a professional designer or engineer would be doing as they design the houses and the buildings that we actually live in. But yet it's intuitive. It's designed to be an intuitive space, one that your students can learn rather quickly. I've trained a lot of teachers on how to do this, and they're always a little nervous at first, but then we find that their students pick it up maybe a little bit quicker than we do sometimes, which is really exciting. And we can design these spaces, and I'm pretty sure I have a terrain ground in here too. So you can search from, I think, thousands of shapes to bring into your design and really manipulate and create this pretty cool space. We could even get rid of this work plane. So the work plane that I'm designing on, I don't actually need it when I'm working with some type of design like this, because perhaps scale is not quite as important as maybe a conceptual model. I could even, let's say, change the background color to look like a sky and make what I like to call, some type of artscape or a theme in this 3D world, which is pretty cool, pretty cool. And your students can, screenshot this, they can share this, they can do cool challenges and activities like this, and they could even browse. And let's say we want to do a room design, we have couches and all these different types of files that we could bring or designs that we can bring in. But you can also challenge your students to design these things as well, because all these shapes can be designed in Tinkercad. And they can design shapes, they can make their own shapes, they can save them under their own creations and things like that to then bring into their own models, which is super cool. And while I designed this kind of quickly, I did pull up this really cool sustainable city design, which I don't think I have enough time to do live on this webinar here, but the concept's the same, where we can take our basic shapes, our basic boxes and cylinders and spheres and the trees and things like this, and bring them all together, where this is a city that's designed to be sustainable with renewable energy and urban farming and some really great things that we see happening all over the world. And we can challenge our students to think about these things and design these things and even to collaborate with one another. I already showed you how you could make an activity where students could be challenged to design this and share this into an activity that you can create. But we could even press this little collaborate button here, and I could invite somebody else to be in here with me designing. So if students were working in a group, or let's say perhaps they were designing things separately, maybe some students designed this building and some students designed the dam and some students designed these turbines, they could then come together to bring these designs together in this collaborative space that we have in Tinkercad, which is really exciting. So lots of really awesome types of projects that we can do as we design and create in the 3D space. One of my other favorite things to do in the 3D space, and I'm just going to make a new design here for this, is to prototype. I challenge my students to work through a design process, an iterative approach here, where I, might allow them to use 3D printing or other materials like cardboard, recycled materials, things like that. And I often challenge them to sketch their ideas, do brainstorming, all those things as they go through the engineering design process and as they're designing these different things like that. And when they're designing their parts, I love them to actually bring in the things that they might use. So for example, I might grab this box shape and I might dimension this, like put in these measurements to be specifically, let's say, a piece of cardboard that I have to work with. So I have a piece of cardboard that's 120 millimeters by 120 millimeters, and I'll make it brown like cardboard. But I also might have things like a paper cup to work with, and I can search and find a paper cup that's actually scaled to what a paper cup might be. And I could look for, let's say, for example, a straw. I might have straws to work with, like this one, right? As we go. And I could design using these real materials that I might actually have to build with here in the real world. And I can see how they would actually fit together and conceptualize this design in CAD. And that is how our real products, the products that we buy and use every day, that's how they're designed. Engineers that are making the cars and the houses and the bridges and all those things, they're simulating their designs in CAD to test to see how they will function, to make sure that they're going to work, to share their ideas, to collaborate with their peers and things like that. And when we challenge students to be designing in CAD, not just for, let's say, creating 3D models or things like that, but as a brainstorming, as an iterative creative thinking tool, they get to experience those same skills. So I can kind of combine my straws here a little bit and bring them together in my prototype. And perhaps I bring my cup up here. I'm not exactly sure how I'd fasten all these things together. I think I'd, in the real world, poke some holes, maybe use some hot glue, something like that. And perhaps I'm designing some type of prototype for an egg drop challenge. Let's see if I can find an egg. Perfect. I'm going to put the egg in the cup, right? And now I can kind of see how these materials might fit together. I can see that, perhaps this cup is a little too big for the egg and I might need to stuff some tissue paper or something in there. And I can sort of design around these items in CAD. Another cool space in Tinkercad, and it's actually built into the 3D editor, is called SimLab. So let's say, for example, I actually grab these items and I lift this up for my, egg drop challenge. Okay. So I'll raise this up a little bit. And we can head over to SimLab by pressing this little falling apple. And SimLab allows us to simulate real-world physics. So this is where I can actually set material properties. So for example, I can click on this brown box and I can actually say that this is something kind of cardboard-esque like polystyrene. I could make these straws all plastic, which they are. I can make this cup into styrofoam, something really light. And I don't think there's egg, but perhaps I can say something like rubber, which might be a similar density. And what SimLab allows us to do is actually apply gravity and real-world physics to these items. So for example, if I were to press play, we would see my prototype fall and the egg stayed in the cup, but I'm not actually sure if the egg would have survived that. But the cool thing is I can actually rewind. I can see where my prototype failed. And I think the lack of hot glue in my CAD model might have been the failure there. But this is another great way that students can be designing and testing their 3D models, seeing how they might function, simulating their functionality in CAD, which is super cool. And there's something newer in SimLab. So SimLab came out, I think, a little over a year ago or so, but a newer feature are these connectors, which is where we can actually apply specific motion rules. So for example, creating pivots or sliders or things like that. So I have, in this example, I have some axles and I have some gears, and I've created pivots, or I'm sorry, rotation connections here, axle connections here, to say that these gears are intended to rotate around these axles, like how they would in the real world. And when I run into SimLab, I can throw something at my gears to see if I can get them spinning there. and we can actually see that motion be simulated. So it's for testing things that you might be doing with gravity, like an egg drop or Rube Goldberg machine or whatever it might be. But it's also where if students are designing models that are supposed to move together and function in some type of motion, they can actually test that out and they can simulate that as well, which is super cool as we go. So another super exciting thing. And I actually first brought this up in a webinar where we were um, talking about robotics, where when we are designing, let's say, robotic systems in Tinkercad, where we might want to test out different gear mechanisms or things like this. I also love using the everyday objects to do that. So just like I showed you the paper cup and the straws and things like that, you'll find everyday objects like electronic components. So we have some wheels and things, and these are typically underneath the electronics section here. And you can see that we have some DC motors, and this is a microbit, and these items are all to scale. So I can't, in the 3D space, I can't program this microbit. You can do that in circuits, which we'll get to a little bit later tonight. But I can still design with it. So if I'm designing a robot and perhaps I'm using this very common geared DC motor, or maybe I need to fit a 9-volt battery, I can actually grab these shapes. And again, these are actual dimensionally correct, and I can design around them. I can use these everyday objects in my design to create this chassis, which this red box here would be the part that my students would actually be 3D printing. And then they would assemble it around these. And of course, I say 3D printing, but we could use this for designing with lasers as well, as we discussed in a previous webinar, where we can export this as, let's say, a 3D file like STL or OBJ or something, or I could download it as a 2D file, an SVG, which in this case, I would want to take this panel and rotate it and flatten it like this, and then perhaps I could download this for laser cutting to cut out of wood or plastic or something, or cardboard, right, as we're designing. And on the conversation of robotics, I personally love using what's called bricks mode. So if I switch to, let's see where we go. Here is another little robot where perhaps my younger students are thinking about how robots function, right? So the challenge might be design a robot that can help people or something like that. So they might design a robot and they could say things like sensors can see things and arms can hold on to things, right? And this is where different components of the robot goes as we have it here. And perhaps they want to build this in the physical world, but they're not perhaps using 3D printing or something. They actually want to build it using cardboard or paper, and they're just using Tinkercad to design. There's also this really fun bricks mode where we can use these plastic toy bricks to build our designs, and we can even set our resolution on how complex we want our design to be. So I can actually see how I could assemble and build this robot out of these toy bricks, which is super fun and another great way to bring our CAD designs to life into the physical world, which is really cool. Now, I think that kind of overviews the 3D design space. I know I covered that quite quickly, but I'm also seeing some questions about the other awesome things in Tinkercad. So something else that we can do is code blocks, which is super exciting. So if I actually leave the 3D design space and I can head over to my code block space, I'm going to create a new code blocks project. And I want to point out that classes and activities, what we saw earlier, works the same with 3D design, with code blocks. So that's, if I made an activity and things like that, if I did a challenge, students could submit a 3D design or a code blocks project or a circuits project. So really, that all works very much the same. But codeblocks is a different type of way to engage with computer science and computational thinking. So you might be teaching, I saw that I have a lot of coding teachers, robotics teachers with us here tonight. And typically when we program, we might be making an app, a game, a website. Maybe we're programming a robot to move or something like that. What codeblocks does is it allows us to use a block-based coding language, right, where I have these blocks like so, and I can drag them out into my little programming space like so. But the difference is we're using those blocks to create 3D shapes. So for example, I just added a cone shape. And if I were to run this program, I have a cone like so. So what I program over here happens over here. So for example, if I were to change the color of my cone and rerun the program, the cone's now red. And I could, customize the size. Maybe I, for example, want to make the, sorry, I'm just trying to make this fit on my screen. Might be a little small for you, but I got to be able to see it here. I could change the size a little bit. And I can see what that does, and I can play with my cone shape here. Maybe I reduce the number of sides and make it a little bit smaller. These are the dimensions that I'm typing in. And I can, manipulate my shapes, all using essentially a code block. I could even, head on down and grab, let's say, a block to move it. So perhaps I want to move it up so it's on top of the work plane. And this is teaching really good computational thinking skills as we are working through programming different things to happen, different logic statements and algorithms and things, and also working on our spatial reasoning skills as well, which is super cool. Perhaps we want to add another shape, and we have a much more extensive webinar on how to work with code blocks and some code block resources that I see that we're dropping in the chat. So while I'm doing a very quick crash course on code blocks tonight, with just some quick examples here, just note that, of course, there's lots of other great resources, but I'm just going to try to design something a little quick for you to see. So I'm just going to add a cylinder and manipulate the size of my cylinder here a little bit as we go. And I'm actually going to turn this cylinder into a whole shape like this. And we're going to move that on top of the work plane as well. Okay, so I should see my whole cylinder coming through here. All right, and maybe what I want to do is, group these things together, right? So I'm going to create a group with my shapes, and we can group them just like we would in our 3D space, where I can manipulate my shapes, I can group them together, etc. Then maybe let's go ahead and we can copy this group. And I'm going to move this here. I'm going to lift this copy up. So let's see what that looks like. So I can go ahead and group it and then make a copy and lift it. And you can speed up this. So if you're running your code quite a bit, I can either run it really slow so I can see each step happen very slowly. You can see that the code's highlighted as I go. But if you're testing this many, many times, you kind of want to speed that up a little bit. It kind of makes your life a little bit easier. And maybe what I want to then do is, let's say, change the scale a little bit. And then I'm going to rotate this just a bit, not 90 degrees. Let's say by like 15 degrees. And let's see what this does. Not the x-axis. Let's rotate around the z-axis. Making lots of mistakes here as we do in coding, but I can troubleshoot and I can prototype. So that's kind of cool. So now I have two shapes on top of each other. But of course, if you are familiar with computer science, you know that this is a key thing about computer science is to make doing things easier, to allow us to automate different processes, things like that, to create autonomous functioning robots, right? So realistically, I'm telling you right now that I think many of you could probably make this very simple shape much, much quicker in the 3D design space than perhaps in code blocks. I know that I can personally, but because we are programming this, I can do automated things like, for example, repeat this, let's say 25 times, and then I can create pretty elaborate shapes as we go here. And that I don't think I can do quite as quickly in the 3D design space as I could in code blocks. And perhaps we actually manipulate the scale here a little bit. Let's try this. Too much. Let's manipulate the scale. Very small amount. There we go. That's pretty cool, right? And then let's just throw in another group. Group my shape, and maybe we can change the color if we'd like. And we have this nice solid part. So challenging us to use our computational thinking skills in an entirely new way. And the cool thing is, in addition to creating these different 3D spaces, and there's so many different things. Again, I really recommend you check out that past webinar where actually another member who's with us, Christian, did an awesome job showing lots of cool projects, including this space, that you could do. We could take this 3D shape. Like, for example, I could export this as, let's say, an STL to download this and 3D print this if I wanted to. I could even bring this shape into my 3D editor space where I can save this. So if I, after saving this, I could head back to my 3D design projects. And now, although there might be a little bit of a lag time, we'll see how quick this goes live on our Zoom. I should be able to see that vase and bring it into my 3D design space. So this was made using codeblocks, and yet I can work with it here in the 3D editor as well, which is really awesome. So another great way to kind of bring computer science into your classroom in a really unique way to challenge your students. And the last Tinkercad space that we're going to be talking about before we switch directions here a little bit is one of my personal favorites, and that is the circuit space. So I'm going to make a new circuits project, and this is very different, I think, from codeblocks or 3D design. In codeblocks, you're making 3D shapes. In 3D design, we're making 3D shapes. In circuits, we are making electronic circuits. So you'll see that the shapes we have to work with are actual electronic components, like, for example, a battery, right? And I can do things in circuits that I could do in the real world if I was working with electronics here on my workbench. So for example, let's say that I didn't want a 1.5 volt battery. Let's say I wanted two batteries. Well, I could do that. I could even use the same type of electronics tool. So if I wanted to measure the voltage, the output of these batteries, I could grab a multimeter and I could wire, let's say, the negative wire and the positive wire, and I could run this simulation. And I can see that my AA's here, my two AA batteries are outputting 3 volts, which is great. So I can test and I can build and I can simulate my circuits, kind of like how we can simulate, let's say, our 3D designs in SimLab. And what that means is that I can design electronic circuits in a really safe space. So I can grab, let's say, an LED and maybe a switch here, and I have these tools to rotate things around, and I can hook up my wires, and I could even change the color of my wires to color code them, like so. And when I run the simulation, we can see that I have an LED, and we can also see that this is too much energy, in this case, too much amperage here, too much current for my LED. So this is telling me, hey, wait a minute, you have too much current going through. So circuits here will actually not only allow students to design and learn about electronics and test them in a safe space, they'll even be able to make mistakes in a safe space and see where they need to adjust. So for example, to fix this, I need to grab a resistor and set this to be smaller amount of resistance and throw this into our circuit. And let's see if we can do this without blowing up our LED. There we go. That looks much better. So a really exciting and safe space for students to be designing their circuits. And this is, I think, a very, very, very simple circuit that we have, but you'll see that there are some quite complex components. There's breadboards and capacitors and potentiometers and sensors and things. And actually right now we're looking at the basic components, but if I switch to all, you'll see that there's lots of different things that you can bring in and allow students to experiment with and prototype with, and motors and solar panels and lots of different things, even a potato battery we want to design with that. So lots of really cool components that we can incorporate into our designs, including, as I mentioned earlier on, I saw a couple people asked about this in the chat, microcontrollers. So you saw that I grabbed the microbit in that Everyday Objects project where I was designing a robot in the 3D design space and I was designing around the microbit. Well, we can design the robot, the physical part of the robot in, let's say, the 3D design space, and I could program that robot here in the circuit space. So I could grab a microbit and I could grab, let's say, a servo motor like this, and I could actually wire my servo motor to my microbit. And of course, while we are doing this quickly, we do have a pretty extensive circuits webinar that I know that we dropped in the chat, and there's tons of great circuits resources for you to learn a little bit more about this in greater detail as we go here. So we have our microbit, we have our servo motor, and then what I can do is I can head over to code. So I can program my microbit in either a block-based or a text-based language. So for example, I can change what's going to be on the screen as we go here. So maybe I want a little heart to show up, and if I run my simulation, my microbit lights up with a little heart, which is super cool. You'll also see that I have this area where I can control the different sensors that are built into the microbit. So the microbit can be tilted, we can adjust the temperature, we can adjust the brightness. It's this brightness sensor. I can even shake the microbit, and I can program using those things. So for example, I could say on shake, let's rotate my servo motor. So if I find my servo motor block, here we go. On shake, I'm going to rotate my servo motor, which is on pin 0, 90 degrees. And then I'm going to wait a second and then rotate it back to 0 degrees. And let's see what happens. So I'm going to run this. I'm going to shake my microbit, and you can see that our servo rotates and then rotates back. So we can program our microbit and see how this would interact as we go. And while I'm doing this in a block-based language, we could switch to a text-based language. This is a great way, I find, as somebody who's taught this with a wide range of students, for them to students to begin to engage with text-based language. Because right now what I can see is as I create a blocks-based program, notice on the right-hand side of the screen, the text appears. So students can see how this would be programmed. This is Python for the microbit, how this would actually be programmed as they go. Or they can switch to a full text project and actually, type their code here as well. And then if we wanted to, we could then download this as a hex file, which can then be dragged onto the microbit to actually upload it to the microbit out of circuits. And like there's a microbit, we also have an Arduino Uno, which is one of my personal favorites, as well as an ATtiny. And this could be wired and programmed much in the same. So you can actually program the Uno in a block-based language like this. You could switch to a text-based language, which would be C++ for the Arduino, like that. And then you can download the code or copy and paste the code into, let's say, your Arduino IDE to actually upload it to the Arduino as we go. So circuits, code blocks, and 3D design, 3 really powerful features in Tinkercad to allow your students to design and make just about anything, from electronics projects to robotics projects, and so much more. And what I want to switch over to is how can we elevate our student skills? How we can get them closer to industry standard skills as they go? How could they prepare for their future careers? And as they get into high school and as they are older than 13 in the United States or elsewhere, depending on your region, they could transition to, let's say, using Fusion, which would provide a little bit more of an industry connection, as well as more career practices where they can bring their Tinkercad designs to a higher level that reflects what a professional designer, engineer might be doing, though I do want to emphasize we are still learning those skills. We're building those skills with all the activities that we just did. So they're still thinking computationally, they're still engaging in divergent thinking and working to create iterative designs through engineering and technology and all those exciting things at a really young age. And we can just continue to build upon those as we provide some more complex resources. Something that you can do in Tinkercad is you can bring a lot of your projects to Fusion, which allows transitioning students from Tinkercad to Fusion a little bit easier to manage. So for example, I'm going to grab an existing circuit. So in Tinkercad circuits, you can kind of browse these starters. So starter projects for Arduino, microbit. If you are just getting started, I saw a couple people saying that they want to learn how to do this. You can kind of reverse engineer it. So for example, you can grab one of these Arduino projects and see the existing code and things like that. But I'm going to grab a basic circuit project. So this is a little RGB LED project here. You can see that I can push the buttons and light up the different lights as we go, which is super fun. And if I wanted to, I could send this circuit to Fusion. So I can hit send to, I can click Autodesk Fusion, and that will bring up a window to name it. You'll see that we have our schematic diagram, although I do want to point out that the schematic diagram and the BOM, the bill of material, is actually created in Tinkercad, which is super cool. And we can send it to Fusion, which would look something like this. So here is that same circuits project, but as a printed circuit board or a PCB, where I actually have my components in 3D here. And Fusion allows us to not only simulate these, see these components, see them in scale, design or printed circuit boards with the circuit project, but actually move into, let's say, manufacturing this circuit, which is super cool, Now, there's a lot of other great things we can do in Fusion, and which I'm going to continue to do here. So I'm going to switch back to our Tinkercad space. And I have this toy car, and I think you might have caught a little glimpse of a little spoiler here. But I have this toy car that we've designed, and this is created with the 3D shapes, the cylinders, and things like that. And we can send this to Fusion as well, much in the same way. And that allows us to bring our 3D designs to Fusion like that. And something that's actually really new with doing this is a very new feature, which is still in beta, I believe. It allows you to bring the design history over as well, which means that I can see all the different things I did down here, from creating shapes, grouping shapes, as I made this car. So for example, I'm going to jump to this section here. You can see this is where I was creating the fin of my car in Tinkercad, which is cool. So we can actually go back and not only manipulate the shapes once they get here in Fusion, we can actually see where they were designed and actually manipulate the design process as they were created when we bring them into Fusion, which is super cool. But with our design and with our design here in Fusion, I could, let's say, for example, modify a face. Perhaps I want to make these back wheels a little bit bigger, so I can make them a little bit wider like this. And for congruity's sake, I will do the same on the other side just to keep it nice and symmetrical for this demo here, right? I could use a manipulation tool like the fillet tool. So for example, I could click on some edges in my design and let's say fillet this, which will be a rounded corner like that. And I can manipulate my design. I could, of course, just design something from scratch too. So let's say that I wanted to actually draw on this fin. If you've never worked with Fusion before, you don't start with 3D shapes like you do in Tinkercad. You would actually start typically with a sketch. So for example, I'm going to create a 2D rectangle. I'm just going to sketch a rectangle like this. And perhaps I want to copy this rectangle or make a pattern of this rectangle. So I have, let's say, 3 of them on my spoiler like that. Then after I've created this sketch, I've drawn a 2D rectangle, I'm going to extrude them to turn them into a 3D shape. Extrude is just one of the many ways we can do this, depending on the type of shape we're creating. But this is sort of like a push-pull, a very common type of way to make 3D shapes in parametric programs like Fusion, where I was just able to pull those rectangles and turn them into 3Ds, into solids. And perhaps we use the chamfer tool, which is kind of like a fillet, but instead of a rounded edge, this would be a slanted edge like that. And now I've kind of added to my Tinkercad design. So a really great way, again, for students to, let's say, elevate their skills and bring them into Fusion. But there's a lot of other reasons why you might want to do this. In addition to having a design space where you can create 2D and 3D designs, kind of similar to Tinkercad's 3D editor, but with some more advanced and real-world industry standard skills. We could switch over to, let's say, a rendering space. And in the rendering space, this is where students can actually apply different materials and textures to make their designs look like they might look in the real world. So for example, I might find some glossy paint here. Let's see if I have any paints ready to go. Here we go. Here's some powder coat. And I'm going to drag this powder coat. And you can see that it actually adds that powder coat texture. And maybe if I switch to metals, we can find a cool metal for my wheels. I'm going to apply it to all the wheels like this. And I'm not going to let this render go because it's going to take a little bit here to do. But what I could do is actually change my, let's say, the camera settings where I can change the brightness of the scene. I can change the background color or even create, let's say, an environment, like put my car on a lake bed like this and change the camera perspective and the exposure and the aspect ratio and actually render a really high quality image to see how this product might look like in the real world, which of course is what real designers and engineers do as they create these things. And another way to do that is to actually switch over to the animation space. So the animation space is where we can actually create animations like animated graphics and videos using a kind of timeline editor here where students can actually animate their projects. So for example, maybe I want to show this car being assembled. And there's a really cool way to do that automatically using the explosion feature, which actually grabs all the components like this and disassembles them. And give me one sec. So I need to redo that here. I got to move forward in my timeline. And now let's try that. I'm going to explode these like this. And when I play this animation, we can see that the car disassembles. So if I was designing some type of project, I could see how it was assembled. And I did prepare one ahead of time, which we did in our animating webinar. So this is an outlet, right, for the US here. And this, if I run this animation, we can see how this outlet is assembled with all the screws coming apart as we go. So students can use this animation window to allow folks to see how things work, how it works together. Or let's say, for example, we want to see how something might move, like this vise. We can actually animate something like this, where the parts move. And you can see at the bottom here, that's a timeline where we are moving the camera, rotating parts, moving around. And again, I recommend if you're interested in doing this, if you're interested in bringing this into your classroom, check out the past webinar on rendering and animating as we go. And another cool thing that you can do in Fusion is you can actually manufacture or prepare your design for manufacturing. So for example, if I wanted to, let's say, I'm going to go back to my toy car. If I wanted to, 3D print this car or even 3D print just this wheel or parts of the car or even manufacture it using a CNC, we can do that in Fusion. And this is not something that you can do directly in Tinkercad. So you can design things in Tinkercad, but we can't necessarily prepare the G-code file, the manufacturing file for 3D printing or CNC in Tinkercad. But what students could do is they could import their designs and then they could switch to the manufacturing tab, which is where they could create a manufacturing file for, let's say, 3D printing, milling, using a lathe, lots of different types of machines for all these different things, additive manufacturing. If I go to the Fusion library, you'll see that there's tons of different machines here that we talked about in our manufacturing window, and we can prepare those designs to be manufactured. And for the sake of time, I'm going to switch to one that I prepared earlier. So here are a bunch of little gears, and you can see that they are on a simulated print bed. And I can actually see how these gears would be 3D printed, where I can actually run this simulation if we can, and I can see the different layer height and infill settings, and this is where I would actually select that I'm going to use, let's say, PLA filament or whatever it might be, add support material, and this could actually be saved as a G-code file, which you could then send over to your 3D printer. And the same can actually be done for CNC projects, like for example, using a CNC mill. So if I had this part and I wanted to actually machine this out of, let's say, aluminum using a CNC mill, Fusion can allow me to do that too, where I can see how a mill would actually go ahead and manufacture that. So we can use Fusion as both a CAD program, computer-aided design, but also CAM, computer-aided manufacturing as well, which is a really exciting and supportive space for your students to be designing in. Now, of course, we've covered so much very, very quickly. So I want to remind you that, yes, this webinar is being recorded. And also in our slideshow, if I head back to the slideshow, let me just flip my sharing here. You'll see that everything I just said live has a slide. So all the things I said has a slide, has some useful links, which the Tinkercad team has been dropping in the chat throughout this evening. So when we share this slide out, you'll see these things. You'll get links to all the things that we've been talking about. So lots of different resources. I do want to remind all of you that for being here, and thank you so much for being here, we are also going to include a professional development certification. Which we'll send to you in our follow-up email that include the slides, the recording, other useful resources. So you'll get your 1-hour PD certificate if you did attend this webinar live. And again, thank you so much for being here and for attending this webinar live. And with that, before we dive into our Q&A, Randy, can I pass the mic over to you to talk about some exciting contests and events and things?
Yes, so we have challenges on Tinkercad, which are super exciting. They're design prompts, which encourage your student to explore different areas. And I highly encourage you to check them out. They're super fun. Yes, so Autodesk Instructables. Instructables is a project sharing website. We have thousands upon thousands of projects, and we have a useful teacher site. So you go to instructables.com/teachers. You can find projects curated rather, not sorted, curated by subject and grade. And there's a lot of great projects, particularly using Tinkercad and Fusion on there. Um, and we also are hosting a series of student contests. We have one specifically for Fusion for the older students, and it's a green future and challenges them to think about what a more green, sustainable future might look like and design things for that future. And it's a super fun challenge, and there's some great entries in there. And it's been extended to June 3rd. All of these contests have been extended to June 3rd, so there's still time to enter. So if they have done the final project and it touches on any of these themes using any of this software, or um, or in the case of the student contest, it's not really software specific. Um, you can still have the mentors not too late. Engineering in the Kitchen is super fun. It's another one with a lot of great entries, a lot of Tinkercad entries also in this one. And it's basically redesigning or designing or inventing things for use in the kitchen, whether that means like adapters for common kitchen utensils or doing full-on science experiments in the kitchen. This one's a great one. And we also have Made with AI. I know some of you in the chat have been asking about AI, and we want students to think about how to use AI as part of the design process, not necessarily to do the homework for them, but to actually further their work and create enhanced designs using AI. So that's another one to check out. And Remake It, which is basically thinking about common household everyday items or items that you think could be improved and redesigning it to make it better. But yes. And finally, Make It Resilient, which is a contest with student scholarship prizes, $50,000 in prizes. In fact, this is a really big contest, and it is focused on students designing structures for extreme environments and kind of how do you make resilient structures environments and kind of thinking about, for instance, making things for outer space or for desert or undersea environments, and thinking about sort of the challenges we might face in the future.
Yeah, yeah, absolutely. And this is where Josh Dobbs has been so involved with the Autodesk team, and something that I'm sure we'll talk a lot about in that interview once we're able to get that shared out to you. Thank you, Randy. Much appreciated. And listen, before we dive into Q&A, I need to just take a moment and throw a huge thank you out to first all of you for being here, all of our educators that are using these resources. We all do this because of you and the exciting things that you share that your students create through contests, challenges, social media, all those things is absolutely incredible. So thank you to all of you for being here and for supporting us. If this is your first webinar, if you've been with us all year, huge thank you. But also for me, just to say thank you to all the amazing people that are here with me tonight and all the folks that have been with us throughout the webinars all year long. And there's so many folks behind the scenes that are making all these things happen. It's a very, very, very complex team doing lots of incredible things. So a huge thank you to the entire Tinkercad team, the Autodesk team, and again, to all of our amazing users and educators, because it's been a really exciting year. And we've talked about so many great things, and I'm excited that we were able to share just a few of them with you tonight. So a big thank you from me and from the entire Tinkercad and Autodesk team. With that, I hope you all have a fantastic evening or day or morning, depending on where you are in the world. And until next time, happy tinkering, everybody.